We'll be looking at near zero energy buildings in Malaysia by Sustainable Energy Development Authority. Ladies and gentlemen, please welcome Mr. Steve Anthony Lojuntin to deliver his presentation.
Thank you very much. Being the second last speaker, I think like the last speaker already. So I've been reminded that to do a quick presentation, but I think in the first earlier of my slide will be already covered by the previous speakers, so I can go faster than it's supposed to be. Okay, my topic is about nearly zero energy building. It is something that we learned from the past 10 years, and then the recent visits to Brussels and Copenhagen, we saw that what happened in Europe basically is not something that difficult to do here in Malaysia, and in fact some of it already done in Malaysia. And I was surprised when we in Copenhagen, one of the document by the Danish government energy agency, at the back of the document, so the three buildings, I mean the government buildings in Malaysia that achieve, according to them, actually is nearly zero energy building. Okay, about the about the introduction, the nearly zero energy buildings. Actually, there's a lot of definitions according to the EU, and then this morning Marina mentioned that still need to define what is the standard range of nearly zero energy building. But for us in SEDA, currently we have a program, we call it low carbon building, which is promoting low carbon until carbon neutral. And then actually advanced low carbon building, more than 50% savings, also considers towards zero energy, nearly zero energy buildings. And it is a step, one step ahead to facilitate towards achieving net zero energy. So what we learn is actually NZEP, small n meaning to say nearly, if big capital N meaning to say achieve net zero energy, or carbon neutral building, by looking into the operational carbons. Focus mainly to building elements that have direct impact on the carbon reductions, which is mainly on sustainable energy, energy efficiency and renewable energy. And since today, since this morning, we heard about talking a lot about energy, and focus on basic, practical, and the most important is viable elements in sustainable building. And it actually, the nature is quantitative, measurable, recordable, and reportable. And currently it's a global race on NZEP in Europe and Japan. And by 2020 to 2030, they wanted to have almost all building, including the residentials, must achieve NZEP. And in Malaysia, it's not something new. Attempt had been made to have actually zero energy building back in 2002. If you heard about this zero energy office building in Bangi, but unfortunately at that time we didn't achieve that zero energy. But still again managed to get 86%, left another 14% is due to technology barrier as well as cost. And I think this one everybody aware, although the artist in the video saying that a lot of people are not aware. Okay, problem, climate change, everybody know that, and now the green technology solutions and living actually is the solutions. In Malaysia, the climate change in charge by the Ministry of Natural Resource Environment and the partner, green technology by KETA. So it's a good partner there. I think this one already mentioned earlier by a series of speakers. And also KETA had presented the green technology definitions policies. But what I'd like to emphasize here, this definition is very important because it will what I call provide you a consistent understanding on green technology and low carbon. If you look at the 5 elements of the green technology, 4 of them actually very direct to carbon, be in embodied or operationals. When there is a program of nationals to reduce carbon from global and transfer, what I call adopted by country, and supposed to be the national should have its target. Like in Malaysia, we have about 45%, and it will be from policy to mitigations or actions, then go a slightly lower hierarchy, urban mitigations like low carbon cities. This is where Malaysia already have its own low carbon city frameworks, and some cities adopted low carbon city society and ICLE and so on, and suppose transfer it to another lower hierarchy like buildings, transportations, infrastructure and so on. And another important fact that we know, report by IPCC is in cities, out of these 5-6 sector, building sectors offer the highest chance to reduce carbon. So for local authorities, this is actually the important fact that if you want to do reduce carbon in your cities, so building is actually the quick wins, because we didn't say that you don't do the other green or low carbon, you do, but building actually is the quick wins because it's offer higher potential of reductions over dollars or ringgit spending. Yeah. And this is the low carbon city framework by KETA, currently championed by Green Tech Malaysia. And inside the low carbon city framework, divided to 4 categories, which is urban environment, transportation infrastructure, and low carbon buildings. So, low carbon building, the high performance low carbon buildings is considered like nearly zero energy building. Another important fact by UNEP SBCI, Sustainable Building and Climate Initiative, saying that in a life cycle of building, the most emissions comes from the operationals, and only 20% within the design, development, as well as the demolitions. So this is an important fact that if you want to make buildings low carbon, so we need to address the most significant most significant features, which is during operationals. And fact saying that out of these 80%, 90% over has come from energy. So if you want to make a low carbon building, address the energy efficiency. The consumption of the building by addressing energy management, energy efficiency, and renewable energy, and so on. So if you address the consumptions of the building, make it energy efficient, and then definitely there's a balance of energy still you need, and offset it by renewable energy. So this is a method that very straightforward, easy to understand how to make building nearly zero or towards zero energy. And the relations between energy and carbon is here. Every 1 kilowatt hour energy we use or generate in power plant is equivalent to 0.741. This is the old data. There will be a new data from Green Tech Malaysia. But this is the thing that numbers of people not aware. They know they participate in Earth hours. They know that, but the rationale is climate change. But a lot of them not aware actually the relation between energy. They switch off the light with the climate change. Sustainable energy pyramid is actually the concept that we always prefer to use if you want to have optimum NZEP, what I call practice or zero energy practice. You start with basic principle of sustainable energy, which is energy conservation. So save energy. By doing save energy, you can save a lot, and sometimes case to case up to 20-25%. And then next, couple with technologies, which is the energy efficiency. From our experience, by couple these two, energy efficiency and energy conservation through energy management as well as awareness, the saving can up to 50%, in some cases up to 70%. By doing that energy management, it's already potentials beyond than 50%. And building energy index also potential to reduce below than 100. So energy efficiency, energy management itself offer chance to reduce energy towards the nearly zero energy carbon. And then if you have more what I call budget, install renewable energy. And currently in Malaysia, to install renewable energy, especially in building, through solar photovoltaic. Last time there is a feed-in tariff, but now they're promoting net energy metering. It is possible to achieve not only nearly zero, but also net zero energy or positive energy. And when it comes to program and so on, we cannot run away from cost. This is the 15 years research have been done by SEDA's officers, although SEDA only just about 5-6 years what I call age, but our staff have been involved in this sustainable energy beyond that, beyond the formation of SEDA. So if you look here, it's very clear between energy efficiency and renewable energy. Energy efficiency offer the cheapest solution in terms of reducing the same amount of 1 kilowatt hour energy over ringgit spending. And we converted to carbon, it's clear that it's within 80 cents to 270 per kilogram carbon over if you use renewable energy about 7 ringgit to 11 ringgit per kilogram. So there will be a mixture between percentage energy efficiency and renewable energy. But from our experience, if you want to have what I call high performance NZEP, give priority on the energy efficiency, because in terms of ringgit spending over the reduction is higher. And NZEP is not new in Malaysia actually. Maybe that time the NZEP words is not popular. It started with zero energy building attempt in 2002. Like for example, this is okay. There's no okay. This is a 3 government building achieve more than 50% saving, and some actually achieve 86%. And this has become a catalyst of in fact green building in Malaysia. For example, new design building, Qatar building, it's not new, it's already I think about 13 years old, something like that, yeah. So it's very advanced idea at the time, but very practical, demonstrating the standard MS1525 code of practice use of energy efficiency and renewable energy for non-residential building. And this is some of the features, energy efficient features, and coupled with in-house energy management and some monitoring team from SEDA Malaysia. If you look at this building, if not energy efficient, if you use building energy index as a reference, because easy to remember the 3 digit, the building will be have a building energy index about 275. And when using daylight and all the what they call it energy efficient features, and design the efficiency according to MS1525, and together with the energy management, airtight and so on, you're able to reduce 56%. This we have promoted this since 13 years ago and still relevant until now. A lot of buildings still struggle to achieve 40-30%, but actually if you go for integrated design as well as operations, you'll be able to achieve that. This is 13 years ago. This is some fact that where the buildings are located. I mean status over the other government building. This is data, all data in 2004, with the extra cost 6% and payback period about 7 years. And the second building, learned from the Leo building, is the Green Tech building, formerly known as Zero Energy Office. As I said just now, unfortunately we didn't achieve zero, but have to change to reflect the reality. Still using green energy, so it's become green energy. But we hope that in the future, Green Tech Malaysia will take initiative to continue the effort to make it zero energy. So these are all the features in terms of technology. Some using first time technology, advanced technology in Malaysia, and become a pioneer. And because it is a project, inside the project, there is a project, another project. to demonstrate the feasibility of technology as well. And if just energy efficiency, it able to achieve 70%. Yeah, that is the status. And coupled with renewable energy, total 85%. Renewable energy contribute 15%, but energy efficiency contribute the biggest. So that is a fact that if you want to have a high performance, focus on energy efficiency first in terms of cost spending. And the third one, actually, the one of the warehouse. I like to use this warehouse because this warehouse have a kind of history effect to the Malaysians, because involve investor wanted to come whether to invest in Malaysia or in Thailand. But at the end, when the building owner offer low carbon building and then managed to reduce design in terms of more than 70% energy, so the clients they have a buy-in and then they invest in Malaysia. So simple one. What they did actually is just simple, common, old technology, daylight. And energy efficient lighting, they're just using the common T5 now, coupled with the cross ventilations, so they can remove the exhaust fan to while still maintain the temperature inside there. And after operations, now it's already about 4 years, we managed to reduce 70%. The building energy index is just 15%. And this is some old project during the NIDA project and JKR, Cawangan Kerja Pelajaran the time. They're doing simulation design, new design of computer lab with some features follow the MS1525, including some energy efficient equipments. So also be able to design more than 50%. So this is the thing that about 13 years ago. Nowadays, I think it's already be able to achieve more than that, because the technology price is getting cheaper and more affordable. How about existing building? Existing building, normally the most systematic way to go towards NZEP is doing basics, energy audit. So energy audit is a very systematic way to identify potential energy savings, and in quantitative method, even life cost analysis. This is the real example, one of the project in Shah Alam. Unfortunately, this warehouse has been sold after they completed. It's an old warehouse. What we did actually, when I was working with the ESCO, we audit this warehouse, no cost, low cost measures. That time the potential is only 47%. So what happened when the owner implement all the recommended saving measures, plus they include energy management. You see the awareness campaign there, able to achieve more than 52 actually, although we put it 50% there, but actually it's 50%. And then a year after that, they sold the warehouse. That is only the office and some industrial building. How about residential? Is residential even much easier to achieve zero energy? Yeah. This is one example in Putrajaya, low carbon P14. In 2010, by just doing simple energy efficiency, achieved building energy index about 8.27, reduction about 61%, compared over the common carbon metric Putrajaya 2010, and with some what they call additional money, the building owner installed solar photovoltaic and make it zero energy building in 2017. Just recently, I think last year, with just less than 50K. To make this house zero energy, investment is less than 50K. If not energy efficient, just install photovoltaic, I think 200,000 or so, not enough. So the trick is do basic things. Energy conservation with energy efficiency. If in Europe they call it deep energy management, deep energy efficiency. Not deep kumar BSEEP. Another thing is, people always said that we don't have building, we only rented a small space, we only a tenant. But actually, although you don't have buildings, within your boundary, within your what I call area that you rent, you should do energy efficiency as well. For example, this is our office in Kota Kinabalu, sitting at Likas Square, Likas Square shopping complex. I was tasked to find a place that's suitable for our office. So we do shopping and so on, definitely a shopping area. And then I select old building. I didn't select the new building, I select old building because by reality, all building have good architectural design in terms of passive design. So I select the what I call the area, the what I call shop lot that facing north. And by doing having that, we retrofit it. And what happened is, what we did actually, we only maximize use of daylight, simple energy efficient T5, LED only 6 bulb, and energy efficient interior design, meaning to say we arrange the what I call workspace, the color and so on, so that it doesn't block the light, as well as promote reflections of the light by daylight or artificial light. And the new things is actually we embed low carbon ICT, because we learn from the Leo building, from the Geo building, ICT actually contribute quite high during the nighttime or during weekend. This is you can see new building, even modern building, they have very high base load. 50% of the base load or 60% come from the ICT that running 24 hours. And some awareness. Okay, this build office actually is a BSEEP demonstrations. We managed to complete it in 2014 when Kevin, what is Kevin? Kevin gone already. Kevin asked me to demonstrate one. So I said, I promised to you, and I delivered. So last time they want to demonstrate only certain reduction. We demonstrate 86% reduction. This is the one that if you go to KK, just drop by. No need to switch on light. Normal lighting. No, we're not using advanced lighting system. The LED, you see the tricky part is when you use daylight, people thought, switch off the light, people thought, oh, tutup kedai. So this is where we need to differentiate between lighting for technical lighting or for interior design. So we learn for the Leo building, learn for the Geo building, and series of that. We install the LED so that people from outside can see, oh, actually the office is open. Otherwise, they thought it's closed. Existing plan and program initiative. The NZEP program, NZEP initiative, actually, you can start now because it's already have ecosystem. You could say, existing professional expert in Malaysia, government effort. You know that there's numbers of like GBR, they have the trend, I think 1,000 of professionals, CIDB, MyCRES, even Green RE and so on. Actually, you can use the same existing what I call professional to utilize for NZEP. And then the government have the low carbon city framework, as I mentioned just now. There's a low carbon building. Low carbon building, if you do properly, you can go for NZEP. Existing standard MS1525, but again, if you want to have a more advanced, I suggest by Marina, every 6 years to update it with more stringent. And for energy management, after building completed, ISO 15000 is there, or some I've forgotten to put there for environment, ISO 14000. There is a guideline reference case available. The 3 building just now is a good example you can visit. Energy efficient products already in Malaysia. Training capacity building have been conducted by series of organizations, not only SEDA Malaysia, Green Tech, and so on, GBI, Green RE, and so on. There's a lot. Even we have experts in building. R&D have been done by series of researchers in university. And incentive, MDV has mentioned, even previously they also mentioned existing incentive. And in SEDA Malaysia, we have the low carbon building program facilitations, especially to local authorities. And even now, we have the net energy metering. So those have achieved a certain level of energy efficiency. You can offset it using solar photovoltaic and under net energy metering program. And actually, outside there, ESCOs. available to do energy efficiency, energy management program, retrofitting, and for solar photovoltaic service provider. And after all of these things, with the mandate given by UNDP BSEEP, AQR, we also currently have the online monitoring system that if all buildings using the same system and connected to the cloud, that way the local authorities, the government, and linked to EMIS and so on, meaning to say the data is flowing, and you will, I mean the government will be able to see how much carbon reduction or NZEP in building in Malaysia on the what I call on the spot. Yeah, this is the online monitoring. You can browse it using a smartphone. Standard available, professional is available, guideline and reference are there. I think that's all. So NZEP is not something new in Malaysia, only changed name from whatever they call it, near zero, whatever, low carbon. And I think, don't wait. I know that some people said it's very expensive to have NZEP, but you start with something lesser and then improve it gradually. So that's my end of presentation. Thank you very much to BSEEP for inviting SEDA become a collaborator. And it's a good experience we learned from here. And then we're proud we become a collaborator of BSEEP, and we promise to continue the two initiatives that have been mandated to us. I mean, the online monitoring as well as the national competency skills training program. Thank you.